everyone. This is the second page of the Chapter 9 review packet on logs and exponential functions. So we're kicking off here with some solving. And I notice these numbers in the directions are wrong a little bit, so this is really referring to 14 through 17. What I really want to reiterate here is that these are definitely not one-size-fits-all problems. Every one of them is going to work a little bit differently. Okay, but I'll try to point out kind of my mindset. They all kind of begin the same way except for maybe that first one, So looking at the first one, I've got log of something equals log of something. But hopefully you catch on to the fact that just about everything on the left matches up with everything on the right. These look almost exactly the same. All you have to do is say, hey, look, this x must be an 11 for these two things to be equivalent. Okay, so that one's not too bad. For the rest of these, I noticed that they are all set up as log of something equals just a number on the other side. And so anytime you're working with that, remember that that number is really the exponent if you were to think of this as an exponential function. And so that's where I would really begin. This is a common log, right? It's a base 10. So if I were to swing this around to exponential form, it would say 10 to the 4th power equals z. And then from there, it's just, it's just a matter of calculating this, 10 to the 4th power, and that gives us that z is equal to, I believe it'll be 10,000. Okay, that could go into your calculator if you needed it to. Hopefully with powers of 10, you don't need to use a calculator, but you could if you had to. So then, like for the next one, I would start the same way. Okay, and I'm going to go 8 to the power of 3/4 equals x. Now this one here isn't really one that I could do in my head, okay, because 8 doesn't break down nicely into 4 pieces. So I would just go 8 to the power of 3/4. And I end up with 4.76 because it told me to round to the nearest hundredth. So 15 and 16 are similar because the variable is in the same position for both of them, right? The variable is here. So after you do your exponential form, that's just your answer. 17 is a little bit different, but we're still going to start it the same way. I'm still going to turn this thing around to exponential form. And that's going to give me x to the 3rd power equals 64. But the exponential function looks different here than it did in the last two. So now I have to think about how I could get that x by itself. And you could think of this as doing a cube root, or you could think of it as doing a power of 1/3. It really doesn't matter. That one you probably know off the top of your head, but in case you didn't, I'll show you how to type it in again. We're going to do 3 math and then look for the x root, 64. We end up with 4 as our answer. Okay, so now moving on. These get into more of the general relationships with logs and things like that. Before I get into these, I'm just going to do a quick kind of side note to remind you how these things work. Okay, so we have the exponential function. Okay, and exponential functions, I'm just going to do the real simple version and do y equals b to the power of x. Now, that would be assuming that our initial value is a 1. In some of the exponential functions, we're going to have other initial values, and that would go in front of there. We usually use an a for that, okay? But that's your most basic exponential function. An exponential function just means that x is up in the exponent. And then you have the log function, which is y equals log base b of x, okay? And the most important thing to know is that these two things are inverses of one another. Okay? And I want you to be to the point where when you see a number here, y equals 5 to the power of x, you can jump straight to log base 5 of x as being the inverse. So when I ask you about the inverse, you should be able to get straight there. The reason that's important to know is because we know some things about the graphs and we know some things about the properties of the graphs, the domain, the range, stuff like that. Okay, so for example, the exponential function, well, you know what, let's draw the graphs first. So the graph of the exponential function, and this is going to be true for any exponential, is going to look something like this. Okay, so it's got a domain of all real numbers, goes forever left and right. The range is only positive numbers, okay, because it always stays above the x-axis. And it has an asymptote at the x-axis, which is really the line y equals 0. So if the log function is the inverse, it's going to be a diagonal reflection of that blue line. It's going to be a reflection over the line y equals x. So the log function is going to go like this. Okay, something like that. Probably should curve a little more, but that's okay. For this one, the domain and range are flip-flopped from what they were before. So the domain, now you'll notice it's all to the right. There's nothing that goes over here to the left. That's because the domain is all real positive numbers, and the range is all real numbers. Okay, and the asymptote here is the other axis. It's the y-axis, otherwise known as x equals 0. So having kind of all of that information put together is going to help us for some of these questions here, 18 through 22. So, for example, what is the domain and range of the function defined by f of x equals 2 to the x power? That's this guy. That's the exponential function. And it doesn't matter that it's a 2 or a 5 or a 3 million. The general shape of the graph and the domain and range are going to be the same. So domain would be all reals, and the range would be all real positive numbers. Okay. And I actually think I'm going to jump down here to 21, maybe 21 and 22, because those kind of go along with this information. And then 19 and 20 I'll come back to in a second. So what is the asymptote of this graph? Well, this, if I get rid of that 30, this is another exponential function. Okay, this is this guy. Putting that 30 in there is really just going to shift kind of where it crosses through the y-axis, but it's not going to change any of the properties of the graph. So the asymptote is going to be the same as it is for this blue line right here. It's the x-axis because it's exponential. If it was specific and said write the equation would be y equals 0. And then the inverse of the function, log base 2 of x, remember this is where I wanted you to see this relationship. If it's log base 2 of x, the inverse is 2 to the power of x. Okay. I might keep going here. Yeah, I'm going to hit 23, 24, and then I promise I'll get back to 19 and 20. So 23 here, domain of the log function with base 5. Okay, so let's just stop there. Log function with base 5, that's basically this function, but with a 5 down there in the base. Remember though, those numbers don't actually change anything about the graph, okay? They do change the curve of it a little bit, but they don't change any of this important stuff, okay? So the domain of the log function is the range of the exponential function when the base is also 5. That would be true. Honestly, that would be true even if you didn't have the base 5 in there, okay? That the domain of the blue one matches the range of the green one. That's what this is asking. And then negative numbers are not included in the domain of log of x. So log of x is this green one. Remember we said that x's can't be negative. That is also true. You can't take the log of a negative number. Okay, so let's circle back to these ones here, 19 and 20. For what values does this describe growth? Okay, so I kind of just told you this was an exponential function, but we didn't talk about whether it'd be growth or decay. I drew it so that it would be growth, but there's an important thing to kind of catch on to here. Growth happens when you multiply by something larger than 1. So the way this is written, if I wanted this to be growth, I would need A to be greater than 1. Not equal to 1, but it needs to be bigger than 1, because multiplying by something larger than 1 makes something get bigger, okay? If it was decay, it would be less than 1, but still not negative. We're talking decimals, fractions, things like that, okay? By the way, I'm a little bothered by this question, to be honest, because we don't ever put the a down there as the base. Really, this should be like a times b to the power of x. The b should be the one being raised to the x power, and then we would say it should be b is greater than 1. Okay? I don't think it would bother me so much if they had used a totally different letter, but a is usually what we use for the initial value. And that doesn't affect whether it's growth or decay. You can start at any number and grow or decay. But the growth factor is the one that has the x on it, and that's where you want to make sure that you're looking at growth versus decay. Okay, and then 20, I guess, is asking exactly what I just said. Now this one, they wrote the equation the correct way. You'll notice, like this one. Y equals AB to the power of x. If we want it to be decay, well, that's when B is going to be less than 1. But you want to be careful that you specify that it has to stay above 0 also. So smaller than 1, but still above 0, because we don't want to talk negative numbers here. Okay, so decay is less than 1. Growth is greater than 1. Okay, 25 and 26 are just practicing having us write this in the other form. So let's see, we've got one in log form. This is where we're just using that circle method. And so this we would say 6 to the power of 3 equals 216. This one here, it's important to notice there's no base written in there. And when there's no base, we assume that it's a 10. So this would be 10 to the power of b equals a. These ones want you to go back the other way. I want you to take exponential equations and write them as log equations. So I would say this is log base x of z equals y. The exponent's always what you end on. For this one, it would be log base 3 of 12 equals n. Okay, that'll do it for this page. I'll leave this here if you want to take a quick screenshot of that or anything. That might be helpful information for you to study before your test tomorrow.